All right, I'm going to try to do this a little better than I did last time. So first of all, distance. How long is that? Correct. That's 4. How long is that one? That one is also 4. How long is that one? Well, that's a little harder. So if I go this way, that's 4. It's going to be a little bit longer than 4. If I lay this thing down, this thing is going to lay down. It's not going to go straight down. It's going to go out here somewhere. So we can use Pythagorean theorem to figure this out. This is 4, this is 3. So we know that a squared plus b squared equals c squared. So I know 3 squared plus 4 squared is equal to c squared. So I got 9 plus 16 is equal to c squared, which means 25 is equal to c squared, which means when I take the square root of both sides, square root, that means c is equal to 5, which like, oh yeah, 3, 4, 5 triangle, those happen all the time, okay? So that's one way to do that. I can do the same thing down here. If I've got a nice little graph, I can just say, oh, okay, let me just make it into a little right triangle here. So this side is 2, and this side is 1, 2, 3, 4, 5. So tell me what the length of that thing is. And we notice it's got to be more than 5. If I was to lay that purple thing down, it's going to lay down somewhere out here. And so it's got to be more than 5. So figure out what that is. So once again, Pythagorean theorem, 2 squared plus 5 squared equals c squared. That's 4 plus 25 equals c. I'm going to go ahead and take the square root of that whole thing. So we're really looking at the square root of 29, which is about 5 point something. I'm going to guess 5.4. I don't have a calculator in front of me. It might be 5.3. I don't think it's 5.5. So brief announcement, and that's going to mess everything up.
Attention staff.
Yeah, it's free dinner. You can tell where I'm doing this.
Please make your way to the quick lunch
All right,
room.
figure that one out. Ignore the announcement.
Attention staff. You may go to the quick lunch room and get your dinner.
Okay, I'm not getting dinner. I'm working with you guys. So what's that one? 1 squared plus 2 squared equals c squared. I got 1 plus 4 equals c squared. So really, square root of 5 is equal to c, which totally makes sense. This is 2. Square root of 5 has to be very close. It's not much longer than 2, but it's going to be very close. And square root of 5, it's bigger than the square root of 4, which is 2, but it's a lot smaller than the square root of 9, which is 3. So this is how I'm estimating. Well, it's pretty close to square root of 4. So this is about 2.1. And once again, I don't have a calculator, but I'm pretty sure it's not 2.2. It might even be like 2.0 something. But it's close to 2, but it's definitely not 2. All right, if we've got graph paper, this is easy and it's worth doing. But if we don't have graph paper, or maybe we're dealing with really gigantic numbers, we can do this, what's called the distance formula. And so the distance formula, once again, it's this right here. And all this is doing, this right here is the x's subtracting from each other. This is figuring out my a side. My y subtracting from each other is figuring out my b side. I'm squaring them, and then I'm taking the square root. It's really the same math. It's just, without using the graph, I can do this with any numbers as long as I know the coordinates. So once again, we know ahead of time. This is another one of our, oh no, that's 1, 2, 3, 4, 5. That's 5. Okay, and this is 3. So I know this is going to be more than that. So I can kind of do that in my head in advance, 25 and 9. But if I do it this way, let me show you how the math looks. Okay, I'm going to subtract my x's. It doesn't matter what x2 and y1 is. I'm just going to say that's x2 and y2. I'm going to subtract them. I'm going to subtract my other x. So I got my x, my other x, and then I'm going to do my y and my other y. So it's square root of 25. When I square that, and that's 3 squared, it's 9. So this is the square root of 34, which is just below the square root of 36. So this is maybe 5.8. Okay, roughly. I'm going to do a little approximately, which is the two squiggly symbols. Now, once again, I don't know. Get a calculator out. That may be 5.9, but I'm guessing. So let's do it again. I want to show you it'll work with any numbers. So take a minute and pick which one of these is the actual setup as far as setting this up. Okay, so once again, I could do it by saying, well, this is 3 squared and this is 4 squared. Oh, this is going to be a 3, 4, 5. But let me show you that the math works. I want you to show, hey, it doesn't matter about the signs. So once again, I'm going to pretend that this is x2 and y2. Doesn't matter. But I'm going to do the square root of negative 3 minus my 1 and my negative 2 minus my negative 5. That's a little tricky, but not really. Those are both being squared. Negative 3 minus 1. I'm moving 1 further down on the number line. That's negative 4 squared. That's my distance of 4 right there. Just figured out my x's. And this is a negative 2 minus a negative 5. Might really be tempted to get 7 there, but this is really negative 2 plus 5. So the positive 5 overpowers the negative 2. So that becomes a positive 3 squared. Oh, look, 3 and 4. And notice that negative is going to go positive when I square it. So that's why it doesn't kind of matter what order, as long as you get your x's minus your x's and your y's minus your y's. So this ends up being the square root of 16 plus 9, which is our square root of 25, which is totally what we were expecting. But the reason I did that one is I wanted to show you, as long as you do the math right, it doesn't matter what the signs are. These numbers could be gigantic. They could be anything. Okay, so now you got to do one on your own. 1, 6, and I'll just make it easy. Let's say that's x2, and that's y2, and let's say this is x1, and this is y1. Figure out how long that line is. All right, this is what the math looks like. 1 minus a negative 5 squared. Now what I've literally just figured out there is along this edge is 6, but this is the math figuring out that edge for me. So negative 1 minus negative 5 is 6 squared. That's my x's, plus the 6 minus my negative 2. 6 minus negative 2 squared. So 6 minus negative 2 is like 6 plus 2. That is 8. And so once again, that's figured out my other edge going up and down. So from 6 down to negative 2 is 8. And then I'm going to take the square root of the whole thing. And so that's the square root of 36 plus 64. Oh, and this is one of our other magical Pythagorean triples, because it comes out exactly as 10. All right, that's plenty. I hope you, once again, if you can draw the picture, I think the picture may be always easier. But a lot of times, if we don't have a graph, or especially if maybe our x's and y's are really big, or maybe they're decimals or whatever, this works, because once again, this figures out my a side when I subtract the x's, and this figures out my b side when I subtract my y's. I square it, take square root. It's basically Pythagorean theorem written in a form that you can use with coordinates. That's all.